So, so far we have studied vector scalar, distance displacement, speed, uniform motion, non-uniform motion, average speed. So this is what is called the Ayodhya part of the Ramayana. This is gone. From now, actually, the ones who will come, they will be the main characters who will go ahead. So the first character whom we will study today, the name of that character is velocity. Children, by definition and book, if you open, it will take only 2 minutes to understand, but you need to have in-depth, good grasp of this topic, because people will fumble this in grade 11 also. So let's understand what is velocity. Now, as you understood, speed is the ratio of distance over time. Okay, velocity is the ratio of displacement over time, right? So few things come in mind. Speed had distance as its parent, velocity has displacement as its parent. Therefore, velocity will always be a vector quantity. That is the first thing we need to understand, because its parent is vector, displacement is vector. So let's look at the SI unit. Displacement is also a type of distance, but it is in a straight line. It is in a distance can be like a Nagin mode. Displacement cannot be in Nagin mode. It has to be like the snooker ball, tuck, tuck, like that. Okay. So straight line means this is also a distance which is meter. Time is measured in second. So definitely the unit would be meter second minus 1 or meters per second, right? Little bit higher end, but you should understand. Little bit grade 11. When we talk about a vector quantity, we represent a vector with an arrow on the head. The arrow does not tell you anything about direction. Any quantity represented with it. We won't see this in grade 9. You would see this in grade 11. An arrow on the head means we are talking about a vector quantity. Let's say, for example, you talk about force. Force will be represented like this. This is a vector quantity. Understood? However, time is a scalar quantity. We will just write it like this. So, but this arrow does not tell you which direction it is going. Arrow means this fellow, you need to get careful. This fellow will have a magnitude and this fellow will also have a direction. Okay. In higher classes, the notation, because when you will go, you should understand this. The magnitude is shown like this. Magnitude is shown between two square brackets. This is called, the square bracket is known as modulus, or we call it absolute value. Absolute value. And this value can never be negative, because in physics, negative does not mean the value is less. Negative talks about direction. If you want to clear your memory, means although you all don't study at home, you studied something called displacement. Yes or no? Yes. Okay. What happened to the camera? You can't see you. Oh, you can't see me? I don't know. People nowadays, I've started to become too much handsome, you know, a lot of demand. So, yeah, you can see me, nice little face. Okay. So, you read about a quantity called displacement. This was a vector quantity, right? Displacement, when you go in 9th grade, displacement is actually will be denoted by S. But when you are in 11th grade, you will denote it like this. S is a vector, because displacement has got direction as well as distance. Displacement has got, anybody who yawns, a displacement has got a magnitude also. Now, imagine that this is a reference point 0, right? And we have a person out here. And this person has a displacement on this side, which is 5 meters east. Agreed? And also has a displacement on this side, which is 5 meters west. Understood? I am denoting two different notations for them. I am saying, let this be denoted by a S1 vector. Why S1 vector? Because this is displacement to the east. Understood? And tradition says anything on right side is taken as positive. So I am denoting this one as S2 vector. Now try to absorb this concept. Are both same in the magnitude? Yes, just the direction is different. So in grade 9, if I consider S1 with a plus 5 meters, I will consider S2 with a negative 5 meters. Negative 5 does not mean that the displacement is less or this is more. They just mean that they have gone in different directions. Understood? Are their magnitudes same? Is their directions are different? In vector language, we will say S2 is a vector which is negative of S1 vector. Nowhere in grade 9, I'm just bringing a little bit higher knowledge to you. This vector is negative. Means if you think that this is an arrow going on this side, this is an arrow exactly going with the same displacement on this side. So this is negative. Have you understood? Now what is the difference between them? Because in a vector, I say there is a magnitude and a direction. This means if I look at the absolute value of S2, it will be always equal to the absolute value of S1. And I told you, absolute values are always positive, means you're measuring. So this will always be a 5 meter, no doubt about that. Sorry, this will always be a 5 meter. Understand? This vector and this vector are completely different. Both have the same magnitude does not mean both are same. We are dealing vectors. Two vectors are said to be equal if the magnitude is same, the direction is also same. Have you understood? Aishwarya Malhotra and Aishwarya Ray are two different persons. It's just like that. Two vectors are said to be same if the magnitude is same. Now, is the magnitude same? Yes. Is the direction same? No. So this vector and this vector are not same. Whereas in scalars, if this would have been distances, you would have said that both are same. You would not have given S1, S2, you would have straight away written S, because the direction does not matter. Is this getting clear now? So when we talk it in terms of vectors, we say these are, one vector is negative of the other. Negative of the other means our values match, but our directions don't match. Is that understood? Because absolute value of both the vectors is 5 meters. Absolute value cannot be negative. Absolute value, what is the value of the force? Sir, 20 Newton. Which direction? Then we will add a plus and minus based on the protocol that we follow. If the force is going northwards, we'll take it positive, right? If the force is going, 1 minute, and this I don't know, always happens with your batch. There's some shani in your batch. Always. One minute, children. 3 classes back to back yesterday, no issues at all. Only when this class starts, this issue will pop up. I don't know. Hey, what is the color of the indicator brand? Just look at the handycam's indicator. Is it black or I can green? Any on the handycam's viewfinder, right on the top. Give me 1 minute. Ah, yes, it's green. Taken up. Okay. So is this concept getting clear? Believe that. Is this concept getting clear? So we are dealing with a vector quantity out here whose name is velocity. In higher grades, velocity will be shown like this. In grade 9, velocity will be shown just like this, because in grade 9, nobody is going to pester you with the direction. All they are going to deal with is only magnitude. But be prepared for the worser part also, because in grade 11, this will come up. And in grade 10, you won't learn anything about it. Understood? And grade 10 is easy. And grade 11 is very tough. So start, whatever you are studying in first chapter is the same first chapter in grade 11. So start learning it with a broader perspective. So what did we discuss? Velocity is a vector quantity, which is a ratio of displacement over time. Whereas speed was a scalar quantity, which was distance over time. The units of both will be same as meter per second in SI unit. However, velocity is a vector quantity. So velocity will have both magnitude as well as direction, just like displacement, right? And velocity will be denoted with a V arrow, means it's a vector quantity. In some old books, they will print it with bold letters. But the right way to represent is with an arrow. Understood? So let's take an example out here, okay? The same person is right now on my reference point, and my reference point is say 0. Say this is in our apartment, our B tower. You can go to C tower also, you can go to, and imagine all 3 towers are in same side. If this person is moving in this direction with a velocity of say 2 meters per second. Mind you, the person cannot move like this, because if he's moving like this, then it is no more displacement. He has to move only in straight line. So if he is moving on this direction, I would say that in V is equal to 2 meters. Understood? Same person, say after he reaches here, he again starts moving on this side, back side. Now, if this is V1, we will say V2 equal to negative 2 meters per second with the same speed if he's coming. So you have to be very careful when you are doing problems. Daily example. You are parking your car straight into the parking bay. If you move forward and you take that velocity as positive, then from that forward position, you'll again engage the reverse gear and it'll come back, then that velocity would be negative. Or if you would have taken the forward velocity as negative, then the reverse velocity will be positive. Is this concept understood? Any questions out here? Yeah, any idiotic question, please don't stop, because maybe few things are also, I've also not explained everything, because the more you question me, the more my mind opens up. Yeah, tell me.
So can you also see the object is traveling in straight?
Yes, a nice question. What Ryan is trying to ask us is, he says that there's a question, the velocity of a, say, a carom coin is 3 meters per second. He's saying, can I assume it is traveling in straight line? It has to. Unless there is displacement, unless the parent is there, the child cannot be born. Child is velocity. Who is the parent? Displacement. Velocity means it is always that the object is moving in a straight line. Then only you are able to capture its velocity. We'll come to a lot of other things. Now is that understood? So if the data of two velocities, say, I have another example out here. I have another example. Let's say we have two data for velocity. Okay. Now let's compare two velocity data. Okay. Let's say I have a data which is say 2 meters per second, 30 degrees east. This is the velocity data, magnitude as well as direction. I have another which is 4 meters per second, 30 degrees east. Question is, are the two velocities equal? They are not, because they straight away fail in their magnitude. However, the velocities are in the same direction. Have you understood now? Say a reverse example of this would be a 2 meters per second, 30 degrees east, and similarly a 2 meters per second, say this is 66 degrees east. Now, are the two velocities same? Well, they would be same only by their magnitude, but overall velocity is not same. Velocity को same करने के लिए magnitude and direction both should be equal. Have we understood this? Okay, now a very unique example. Okay, let's see one nice unique example. We'll come back to that same slide once again, don't worry. So let's say this is a DVD. This is a DVD. You know what is a DVD, right? I thought you'll only know what is Netflix in it. So this DVD is spinning and spinning on its pivot. And the DVD's spinning speed, say suppose the DVD spinning speed is 600 RPM. You know what is RPM? Rotations per minute. So once the DVD starts, how does it start? And then it's taken up its speed of how much? 6,000 RPM. Have you see? I always say next time onwards, when you travel in car and you sit on the front seat, always have a look at the speedometer panel. There are some two gold dials. Do you see? One is the speedometer. What is the other one? What is the other one? No.
Yeah.
The other one is called a tachometer. It will tachometer, T-A-C-H-O. It will tell you what is the engine RPM. If your dad's or mom's car is a manual car, every time she engages the gear, you will see the sound coming like this. So once you press the accelerator, the RPM will go up. After the vehicle steadies, the RPM will come down and it will settle something around at 2000 RPM. In 2000. In 2000 means whatever you are reading, 1, 2, 3. If you're reading 2 means it's at 2000. So the engine is rotating at 2000 RPM. Engine keeps on rotating at the same speed. Once the engine has been started, it will keep on rotating at 2000 rpm unless and until you are exploiting it. But your speed keeps on changing and reducing. That's the mechanism what the gears are going to do. That is where the gears come into effect. They will slow down your car, but the engine is always moving at one continuous rpm. Have you understood? So this is my DVD which is spinning right now, right? Now when it spins at 600 rpm, which we'll later understand. This motion is called circular motion. Don't bang your head on this. Just try to understand. This is a circular motion because you're moving in a circle. And is the speed uniform? I'm fed up of it. Okay. There is something which causes. Okay. Again, this is highly sensitive. I mean, 1 minute. Yeah. I have to put some swastik symbol on that. Okay. This is a circular motion because you're moving in a circle. And I call it something like, though may be difficult for you to understand, but enjoy physics. Uniform circular motion. Uniform, why? Because the speed has now become constant. How much is the speed? The speed is 600 rpm. The DVD is rotating. My question is, let's find a point out here, okay? Let's find a point out here. And let this point be marked as A. So A point is also rotating at 600 rpm, obviously. Can I call this as uniform velocity? This is something interesting. Can I call this as uniform velocity?
No.
No. Why no? Why no? Why no? See, if you want to, it's very easy. If you want to differ with me and say velocity is not same, then two things are there. Either hit your answer from the direction perspective or hit it from the magnitude perspective. अब इसको सोचो. When it is here, it is rotating at what speed? 600 rpm. When it is here also, it is rotating at 600 rpm. Do you agree? Then why is the velocity not same?
Its direction.
Its direction keeps changing. Its direction keeps changing. Imagine if A was let loose. A is a bacha, and this is a merry-go-round, and the bacha is not holding, or the bacha's that particular string broke off. A will fly out. Yes or no? How will A fly out? We always say A will fly out. A will fly out tangentially. It will fly out in this direction. When your A has come here, say A has changed its position somewhere here, A will fly. A will fly out. I wish I get the. A will fly out in this direction. Every time it is flying out, it will fly out with that 600 speed. But the direction and the displacement will take up is different. Therefore, one common question which is even asked in job interviews, this is in grade 11, people call it UCM. Uniform circular motion. Is uniform circular motion uniform velocity? No. Speed is uniform. This is uniform speed, but not uniform velocity.
Velocity, everything.
Yes, why not? Velocity can be, these are all hypothetical, but it can be uniform. Imagine, Adya, ऐसे question पूछना चाहिए physics की class में. Imagine you have a straight stretch of road. Straight stretch of road. And in this stretch of road, you are covering equal displacements. You actually made my job easy by asking that question. Equal displacements in equal intervals of time, no matter, what should I write now? How small, yeah, very good, how small the time intervals are. In such a case, I will say my body is moving with uniform velocity. I did not write one thing which is important, that this path should be his path should be a straight line. जो कि real life में possible नहीं है. You believe that the ORR is straight, maybe to some extent, but somebody watching you from the Uranus or a planet like Neptune says, look, that girl is going in a curve. Right? So if you are moving on a straight line and you are covering equal displacements in equal intervals of time, say in 1 hour you are covering how much? Say in 1 hour you are covering 50 meters, 50 kilometers. Then we are adding how small they may be. No. Check him in half an hour. Sir, in half an hour, the person covered 25 kilometers. Oh. Check him in 15 minutes. Sir, in 15 minutes, he covered 12.5 kilometers. Oh. Check him in 7.5 minutes. Sir, in 7.5 minutes, he covered 6.25 kilometers. Oh, he is covering equal distances in equal intervals of time. So his velocity is uniform. And if a person is not traveling in straight line, first of all, then there won't be the question of velocity at all. But you want velocity. So you have to make him travel in straight line. However, ensure that he does not cover equal distances in equal intervals of time. Then what does it become? Non-uniform velocity. Are you understanding? Why you have to have it in straight line? Because if it is not straight line, the concept of velocity itself is not born. The concept of velocity gets its birth only when there is displacement. Displacement can happen only when you have straight line motion. That's why I said we will change the name of this chapter. This chapter is not motion. And we can change it now. This chapter is motion in a straight line. We are not going to, so I'll write that slowly and we'll change it further. This chapter, which was name was motion. Motion matlab, you can go Nagin dance, whatever you do. But on that, is displacement possible? If displacement is not possible, is velocity possible? No. अगर उनको पढ़ना है तो इसको टाइट करो. Motion in a straight line. And then we will tighten it further. We'll tighten it further. Yes. Rotating ceiling fan is all our examples of speed, not velocity. But in higher grades, we can find velocities at a point, but they won't be uniform velocity. Uniform velocity हो ही नहीं सकता. Uniform velocity के लिए the first thing is straight line. Is the motion a straight line motion? This is a circular motion. This is not straight line. So in real life, you won't get these things. That's why the car never gave you a velocity meter. You don't go straight out from your apartment, then you bang and fall on that lake, then you hit 3 buffaloes. Is it possible? No. So you go by distance. Beta theek ho bhi. So you go by distance and you are covering distances in intervals of time. That means what? You are encountering speed. Even rockets and all which are launched also, they will say initial, jahan tak seedha ho, till there is velocity. And straight does not mean like this. Straight means straight line. It has to be a straight line. But that is very, very arbitrary. Is the concept of velocity clear? Okay. So whenever you are dealing with problems, you have to first see, suppose you won't get that complicated in grade 9. Suppose there are 2 different type of movements. One movement is happening in this side. One movement happens on this side. This we will typically, let's understand one scenario. You can say, sir, why are you complicating all these by saying this type of scenarios? Let's see one scenario. Let's see one real life scenario. Ready? Okay. So we have some brats on the road. Becoming like Peppa Pig's car, nowadays. So we have a vehicle, okay, and we have another, say, sedan. Okay. Head-on collision. ये भी हम पढ़ेंगे. Head-on collision. So after impact, what may happen? What all scenarios are possible? ये गाड़ी इसको भ्रंग करके ले जाएगा. In that case, this car's velocity is in this direction. This car's velocity is in other direction. So there you have to be very careful. These are called problems on elastic collision. This will come. This will come in later chapters. So or else it can be that both of them hit and both, like carom coins, you go this side. Now initial velocity on this side will be in If I take this as positive, this velocity will be negative. But however, after the impact, this velocity became negative. This velocity will become positive. ये समझ में आ रहा है? Everything, एक minute. Everything happens like your Cartesian coordinate system. Do you read this axis or not? Here, what does it say? The more right you go, you are on the positive side. This is positive. And if you go this side, it is called negative. ऋषिका, अभी अपना दिमाग से सब निकाल लो, सब सुनो. दो गाड़ी आ रही है. This car is coming with, say, 20 meters per second. This is coming with 40 meters per second. This is velocity. But we have to assign signs. ये गाड़ी किस तरफ जा रही है? अरे मुझे मत देखो, इसको देखो. Straight मत बोलो. Direction. अच्छा. Which direction? अरे this car is going in which direction? आप रामायण देखते हैं? There they show a battle of arrows. So just tell me, which direction is this car going? See, the more you say reply like this, the camera again goes off. Already we are troubling them, whoever is online today. Okay. I should switch on. I think I should replace the battery of that camcorder. Then bear with me. It will come up. Tell me which direction is this? This is car 1 and this is car 2. Car 1 is going in which direction? 1 minute, huh, children? Arey, 1 minute. Now, when I go near the camera, it will turn on. That's the problem. I don't know. I don't know. There is some Rahu that is there in this room. That is for granted. Otherwise, it should not have behaved in this manner. तुम्हारे लिए होता है. जो भी गड़बड़ है तुम्हारे लिए. आ गया था ना? देखा? हाँ, यहीं पे खड़े होके पढ़ाता रहा हूँ. Okay, now it will start. It's so that is so disturbing, you know. First of all, the flow goes away, and then what question you're asking? By this time, Rishika will think of 5 more utpatang answers. Yeah, madam, I'm asking you a simple question. This is like an SUV. Which side it is going? अरे किस साइड जा रहा है वो तो बोलो ना. फिगर देख के समझ में नहीं आ रहा है. Towards the right. So when we do problems, I will assign this velocity with a positive sign. Understood? ये इस तरफ जा रहा है. ये किस तरफ जा रहा है? लेफ्ट की तरफ. तो ये velocity को हम नेगेटिव लेके करेंगे. In later chapters, that's I'm trying to explain you how velocity works. Then collision happens. Dham. After collision, both move this way. Now, after collision, it has a velocity of 10 meters per second. Now, you tell me, what sign should I put here? After collision. This is before collision. Minus. That's what I'm saying. And for this one takes a speed of 20 meters per second. What should be its sign? Plus. This is the beauty of velocity. If you are wrong with these, then you will be goofing up the whole problem. So this is what you have to understand. Acha, tell me one more thing. Suppose I'm a new mathematician. I take all these sides as negative. Still my answer will come correct, provided I take all these as positive. But do not interchange. अगर आपने इसको positive ले लिया, then maintain that throughout the problem. But the issue is that here. But the issue is that never happens. We will always go by what? The protocol. The protocol is anything to right is taken as positive. Anything to left is taken as negative. This was just an illustration. Have you understood how velocity becomes positive and negative? Okay. So, yeah. Then their velocities after collision is 0. It can be something like this. Now you're deviating to collisions. Suppose you are going and banging a metro pillar. Do you expect the metro pillar to move? No. So the metro pillar speed will be 0. Obviously, your speed, either you'll go and just bang and stay there. So your velocity after the impact is 0, or you'll come back. Like in caroms, we take a rebound strike. So we're hitting the carom strike northwards. That's a positive. And then it goes and hits the bar and it comes back. At that time, the carom striker is moving to a south direction. I'll take that as negative. Understood? Any other question? In these, many scenarios can happen. Both the vehicles can, this one can straight bang it and take it away. Yeah. यहाँ पे फोर्स की तो बात ही नहीं है, फोर्स तो पढ़ ही नहीं रहे हैं हम लोग अभी. आगे बढ़े. So this was the topic of uniform velocity. So if you know uniform velocity, you also know non-uniform velocity. So for non-uniform velocity, you will be moving in straight line, but you will be covering unequal distances in equal intervals of time. In the first half an hour, you covered a displacement of say 50 kilometers. In the second half an hour, you're covering something like say 23 kilometers. So that's non-uniform. Now let's look at their graphs. Graphs are very important, okay? Velocity will be always shown over a graph of displacement and time. We'll cover this again later. So this will be my displacement. You remember in speed, we used to show it over distance, displacement, and this will be my time axis. And if you are following uniform velocity, then you're, acha, one more concept which the graph book that you use is not graph. What you have drawn now is also not graph. Graph is what you plot. This is the graph. The run rate curve that you see in a cricket match, that is the graph. People think this whole thing is graph. This is the graph. So the graph plot between displacement and time has to be a straight line when it represents uniform velocity. Obviously, because equal displacements in equal intervals of time. It may not be at 45 degree. It can be at 30 degree, 60 degree, straight line. And I told you once in physics, this is called straight line. Aadha knowledge very dangerous. Straight line, standing line, slipping line. There can be only 3 type of lines. Slope बाद में. Slope में slope हो जाएगा. इतना समझ में आया? Did you understand velocity? Okay. Our next character in this story is acceleration. Acha, just for your sweet little memory, what all did you study so far? Distance, then speed, then velocity. These are three characters that you have studied. Scalar, vector. Agreed? Unit, meters. Oh, you also studied displacement. This is also meters. Speed is meter per second. Velocity is also meter per second. However, in grade 9, we will be more dealing with this. ये सब टाटा बाय बाय हो गया है. Okay? And in speed, we went and visited somebody also whose name was average speed. Total distance traveled by total time taken. And now we have come at velocity. Okay? Now please understand, from here your life will get a little bit troublesome. Acceleration is defined as change in velocity over a time. To understand this, we will again go and visit velocity. We'll again visit velocity. Achha, what did I initially make you write? Velocity is displacement by time. Displacement by time. There is nothing called an accurate measurement in physics for anything. What is your age? You say my age is 14. Because you assume that when you were born, your age was 0. So the difference we always measure in physics, we are always measuring difference. Difference of your age today as compared to the day you were born was how much? 14 years. That's why your age is 14 years. So when we talk about velocity, we will say change in displacement. Change in displacement over time. Now, how to understand this? Suppose there is a body which, suppose, is at this position A and then has moved to a position B. Agreed? The time when it was at A was TA. TA is some 8 o'clock, 23 minutes, 44 seconds. To move till here, the time, this is the time at this point, right? At TA, what was the displacement of the body? 0. Is this getting clear? So I call that displacement as SA. SA is the displacement at the time TA. What was the displacement? 0. At TB, my displacement is SB and the displacement has been 50 meters. Right? Now if I try to calculate velocity, I will say change in displacement. In order to get the right sign, in physics, change is always final data minus initial data. And what is your data here? Your data is displacement. ये समझ में आया कि नहीं? अरे say yes or no, my dear. Did you understand this? Final displacement minus initial displacement over time. The time should also be the time elapsed. The time elapsed. So what will be the time elapsed? Time is something which always increases. There is never negative time. Negative time is only there in the stories of ghosts, bhoot, pichash, yaksh and gandharv. They only can travel negative. Time negative नहीं है. Time हमेशा चलते रहता है. So our time elapsed will be TB. Our time elapsed will be TB minus TA. If I want to better this equation up, I would write it as SB minus SA divided by TB minus TA. Agreed? What was the time here? Say the time here was 10 seconds. Clock was showing 8 o'clock 10 seconds. And the time here is 8 o'clock 20 seconds. So how much time elapsed? 10 seconds elapsed. Are you understanding? Which one did you not understand? Say. Change in displacement. What was your displacement at A? 0. What is your displacement at B? 50 meters. So what is the change? Final minus initial. In physics, we never do initial minus final. In your PT1, you scored 10. In your PT2, you scored 14. How much is the change in your score? 14 minus 10, which is equal to 4. Is it positive? So that's a green signal for you. But in your PT2, if you scored 8, then how much is the difference? Negative 2. Your face should be sad. Understood? So in physics, change is always final data minus initial data. Change in temperature. Final temperature minus initial temperature. Change in pressure. Final data, final pressure minus initial pressure. पर हमारे लिए इस चैप्टर में डेटा क्या है अभी? Displacement. So final displacement minus initial displacement. Have you understood? Similarly, it will be final time minus initial time. Is this understood? So I said that the time here was say 080010 and the time here is 080020. Then how much has the time elapsed? 20 seconds, 10 seconds. Understood? So हमारा velocity कितना निकलेगा? How much did you move? 50 minus 0 over 10. So your velocity is how much? 5 meters per second. This is how velocity comes up. It's always a change in displacement. Understood? Clear? So now getting it a little bit more advanced. Any change in physics is denoted by the quantity delta. Note that. This is called delta. So there are 3 physics quantities. Triangle stands for capital delta. That's why they say that the LCA, what is India's LCA named as? Light Combat Aircraft of the Indian Air Force. What is the name of that aircraft? Tejas. Tejas has got delta wings. Triangular. We call it delta. We can't call it triangular wings. Chicken Manchurian, not butty piece chicken, a lot of lehsun in it. Chicken Manchurian. Delta wings. Okay, this is called delta. Then this symbol stands for. This symbol stands for. This is small delta. Small delta.
So any change in what is the
Any change is represented by change means delta. I'll come to that. We say, right, that the business has done quite good this year. How much has been the delta? Around 40 crores. That means 40 crores is the difference of profit over this year. You should learn this. This delta means small. And in 11, you'll study something called dy by dx and d. This is called del. ये और छोटा है. This is even smaller delta. इसको del करके पढ़ते हैं. हम इसके साथ बहुत डील करेंगे grade 9 में. Capital 1 is known as delta. So how to read delta is something like, so you said that the displacement, the difference in displacement was what? SB minus SA, right? I will write this quantity as delta S. Delta S stands for the change in displacement. Delta T, capital T, is change in temperature. Delta V in electricity will be the change in voltage. Delta I in electricity will be the change in current. Similarly, the change in displacement. So how will I represent what you call time? I will represent it as delta T. Delta T is equal to TB minus TA. So if somebody wants to, okay, these are nothing with acceleration. We are talking all in terms of velocity. So velocity V will be written as del S over delta S over delta T.
delta S is a
Delta means anything change.
S is change.
Yeah. Delta honesty means earlier you were very honest, now you have become dishonest. So the delta is negative. His delta honesty factor is negative. That means slowly, day by day, he's becoming. See, what did we say? Something interesting. I'm saying his delta honesty. His delta honesty is negative. So let's see. Negative means it is his final honesty minus initial honesty. And this quantity is negative means today he is less honest compared to what he was. Obviously, he's becoming a teen now. So his delta honesty will be lesser. But those mama's boys, mummy, their delta honesty will always be positive. है ना? तो झूठ नहीं बोलता है. Are you understanding? हमने ऋषि का क्या मुंह ऐसा करके बैठते हो? I don't know. Sometimes you pull up satire also, then also there is no change in face. Okay, Ahan, have you understood this concept? What is delta means? Delta is a very common thing that we use. What is the delta? So sometimes they say, na, if you're going from VXI, if you're going to the ZXI variant of this car, the delta is around another additional 80,000. Is it worth it? Clear? And delta is always measured over final minus initial. थोड़ा advance पढ़ो, नहीं तो 11 में it will be like somebody's pulling your nails. If you read that fairy tale physics of grade 6, is this clear? So I'm wiping this off now. So if you have understood what I have explained to you, then I'm just putting some nomenclatures out here. And the nomenclatures will be something like this, that this quantity is delta T, this quantity is delta T, and this quantity is delta S. Therefore, velocity is said to be the change in displacement over the change in time. Now, something more interesting. You need some artist impression for that. You need some artist impression for that, okay? ये acceleration को मिटाओ यार. ये तुम लोगों को बोर करता रहे. तुम मजा लो. अच्छा, in speed we talked about something called average speed, instantaneous speed. Average speed is total distance traveled. I went from here to Bombay. How much I travel? 700 kilometers over a time span of 7 hours. What's my average speed? 100. It tells average. Osatan, he traveled at 100. But did I travel 100 every time? No, I must have enjoyed at McDonald's, right? Or I must be having food somewhere, or I must be paying toll. It was not 100. So average 100 means sometimes it went above 100, sometimes. What is the average price of potato at Ratnadi? 30 rupees, sir. But was the price 30 rupees every day? No, someday it was 35, 32, 31, 33. So you get a zigzag curve, and when you try to draw, so your mom will always think the average price is 30, give her 50 rupees, she will not land up in problem. That's how we do it, right? Now try to understand the concept out here, okay? Now see, okay, let's say, again, always girlfriend in the drawing, no doubt about that. So let me clone the girlfriend first. E. अरे तुमको ऐसे पढ़ाएगा नहीं तुम्हारे स्कूल में, इसलिए तुम रट्टू तोता बनते हो। इसका मजा लो, मजा, right? Now this is a time interval. This is, now don't bang your head on negative positive out here, okay? This is a time interval T1 and this is time interval T2. Try to understand. Road is absolutely straight. Here there is a displacement S1, right? And here there is a displacement S2. I'm not saying she is moving here also and she is moving here also. And suppose her journey, where is it gone? Very careful. Yeah. Leave it. So suppose this girl is riding on a straight line from here onwards. Don't imagine here. Our frame of study is between this. So her zero is there. So she has moved, say, 300 meters. And here it was how much? 200 meters. Are you understanding? Every time it will not be that SA is 0. So how will we calculate her final displacement? S2 is 300. S1 is, say, 200. So what is the displacement she has encountered? Final minus initial, 300 minus 200, 100 meters. And she started at a time, say, 0 seconds from there. Time elapsed till now is 120 seconds. And the time here was, say, 60 seconds. So the time elapsed from here to here is another 60 seconds. Is this scenario getting clear or not? Right. In such a scenario, if I actually try to find out, okay, if I try to find out what is the velocity of this girl, then I would say it is a delta S over delta T. And what is delta S over delta T? S2 minus S1 over T2 minus T1. And this gives me the velocity of the girl. Is there any issue? No issue. Isn't it total displacement between T1 and T2 over total time in this interval? Are my dear children, suppose this is your analysis, study analysis. You are studying it from T2 minus T1, okay? This is equal. The problem is that this software is not activated, so I don't get, and the writing comes good on this. That's the reason I use this, no other fascination. Okay, so say suppose you are analyzing her from in between just these two intervals. Are thoda sa samjho, don't give so much of a this much. A movie is 3 hours. You are trying to edit only this much portion. Your analysis is on this portion. Have you understood? So in this portion, what is the total displacement? S2 minus S1. What is the total time? T2 minus T1. Then can I also not then say for the place from 1 to 2, the average velocity is equal to delta S over delta T. This is average velocity. Total displacement over total time. Have you understood? We told you one more thing, that what is instantaneous velocity? What is instantaneous speed? I said the traffic police finds you, clicks a picture. It is your speed at a particular time. The traffic police says, sir, overspeeding ticket. And you say, no, speed to kam hai. And it immediately pulls out a photograph. And in that photograph, the first thing will be the time. when you were maybe 200 meters away also, his speed gun has actually clicked your photo. By the time you came to him, you have slowed down. So he will show you at this time, Yasvira, you're bound to pay the fine. That is called instantaneous speed. And the car speedometer always shows instantaneous speed. Every time you look at the speedometer, look at your watch. At this HHMMSS, what was the speed? Now a little bit of grade 11 story, okay? Just try to appreciate what we are saying. Acha, children, tell me, how much is your delta t? Your delta t is this much, right? Which in this example, we said 60 seconds. 60 seconds is almost an hour. 60 seconds is almost a minute, okay? Now say, what I try to do, I reduce my delta t study. This much? Okay. I say, observe her motion between these two intervals. Right. Observe her motion between these two. These two means this one and this one. Okay, children? One will be always this. Now observe between these two. Is the delta t reducing? So obviously the delta s is also reducing. I say nahi. और कम में देखो. Theoretically possible. You said, sir, इससे कम और क्या करे? और कम करो. That is the birth of calculus. और कम करो. Then you get fed up. कितना कम करूं, sir? I said so much that delta t should almost tend to 0. Now this is what is in, you might see these examples in grade 11 book and diagram. 10 to 0. 10 to 0 means, do you understand? Very close to 0, but not 0. When me and my sister, we used to fight in childhood days, we used to fight like, first we will hit one another, then my mother will come and say, don't hit each other. Then you know what we used to do? Play with the temperament. I will hit just in front. Laga to nahi na? You will just I'll try to slap her just in front of the nose. Laga nahi na? Until it hits you, you can't complain. So now what is the distance? There is still a separation, but she will get the irritation as if I am hitting her. Are you understanding the pain factor? So the time we are trying to reduce as such that bring it to 0, but not 0. So now just see and observe my eyes. Earlier, I used to watch this girl cycling like this. Now, a little bit later. Now, a little bit later. Okay? Then you said reduce it. Now, this. Now, this. No, sir, bring it more closer. Now, this. Now, this. More closer, sir. Now, this. Afterwards, can I nod my head? I am watching her only at a particular instant. Instantaneous velocity. That is in physics, they say, when you go to higher classes, they will say, can I just change the screen just for 1 minute, okay? That is just to understand, what is the definition of instantaneous velocity? Okay, instantaneous velocity. They will say, instantaneous velocity is delta s by delta t with a condition that this should be very small, and that condition in calculus is called limit. You introduce a limit to delta t and you say, watch out for this ratio. Watch out for this ratio, not like this, like this. A tennis match is going on and I'm seated on the side. How do you watch? Tuck, 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 tuck. Reduce the court length. Tuck, 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 tuck. Reduce it further. But there should be some gap. Assume two ants are playing tennis. Tuck, 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 tuck. Now how will my head move? What I'm seeing? Ball at a particular place. Instantaneous velocity. This you learn in grade 11. You have nothing to do in grade 9. Don't write it. But just try to appreciate the beauty of physics. When you see it over a broad span, average. When you see it on a very small span, such that the span is almost negligible, instantaneous. I saw you now. I saw you 5 minutes later. No, sir. See her in a very short interval. Okay. Within 1 minute, I'm trying to see her. No, sir. Reduce it. Okay. Between 15 seconds, I'll try to see him. No, reduce it further. Then what can be the smallest? The blink of an eye. After that, the human eye is full. So did I see any change in him? Instantaneous vision of him. That's instantaneous. Whenever you read about any instantaneous quantity, instantaneous means the difference of two quantities observed over a very small period of time. Whatever you see is instant. क्योंकि फिजिक्स में जैसे हम कहते हैं ना, अभी अभी उसको देखा. In physics, between the time you speak that, time has gone away. What I am seeing you now and how I saw you as the class started today are two visions of you which are differing by almost now 1 hour. Agreed? So in physics is different, although you have not changed anything. But the same thing if I do with you for 6 years continuously, you'll slowly be a lady, isn't it? So there we will see what is our average growth happening. But if I see you, keep on seeing you at a blink of an eye, that is an instant. And instantaneous, you never see any change. Yeah.
So the close to zero can be subjective.
Close to zero is not subjective. The entire calculus is based on that. Rather, people say like this, close to zero, you can come from the negative side also. You can. I'm supposed to touch his nose, but don't touch the nose. Can I not touch the nose from the left hand side? Can I not touch? Say flat number 1403. How can you approach it? From 1402 to 1404. So in mathematics, they become left hand limit or right hand limit.
You're comparing it for another quantity.
Huh. Subjective. We're very subjective. But you have to define. How does a robot understand? You have understood it. You have to make the robot also understand. Your parents sometimes tells you, जाके अच्छे अच्छे आलू देख के खरीद के लाना. Buy good potatoes. What is the definition of good? Potatoes which should be fresh, potatoes which should be long, potatoes which should be more stout, potatoes which should not have cut marks, potatoes which should not have moist marks. And tomorrow you built a new, what you call, robo. The robo's name is Ramu Kaka. Now Ramu Kaka robo has to be sent to buy potatoes. You have to program him, Ramu Kaka, please buy good potatoes. Now what is the good potato programming that you do for Ramu Kaka? Don't you think you have to include the entire schema of things? Ramu Kaka may bring you everything but kata hua. You did not say that cut marks were to be aborted. So you learn something more. You again refine the program. Next time don't bring cut marks. तो सड़ा हुआ पोटैटो भी लेके आएगा, उसको क्या पता? So when you talk about AI, इतना कुछ है. AI is all about talking. Somebody tells me what is AI, I say AI is talking to your teenage daughter or boy. The way a teenage daughter or boy behaves, अभी नहीं जाऊंगा. Get up, no, not now. Cinema छोड़ दो, सोने जाओ. नहीं, सुबह उठ जाओ. थोड़ा और सोने दो. AI is like that. You go, garbage you enter, garbage will come out. That's the idea of what we call prompt writing. The more better your prompt is, the more better it will be. Precise. AI does not know. आपके मन में बहुत ख्याल है about this girl Rishika, and you want to build a character sketch of her. So you have to feed as much as input data. So more is the data capture strong, more will be the model strong. Clear? Can we just touch acceleration a bit? So, ये तो छोड़ दो. So our next person in the Qatar is acceleration. And acceleration is said to be change in, and we will study acceleration again in next class, but little bit you should know, this is like when the serial ends and they show what is going to happen in the next episode. So change in velocity over time. Now, how can you write acceleration if acceleration is represented by A? Okay, now first thing, is velocity a vector quantity? Yes, if my dad is vector, I am also vector. So this will be written as delta V over delta T, change in velocity. And what is delta V? It is a V2 minus V1 over delta T. What is V2? Final velocity. What is V1? Initial velocity. But since it is velocity, we just love them. We call final velocity, we give a special notation called capital V, and initial is given U. This is another new start to your physics. So how do we represent acceleration now? Sir, if you are in grade 9, the magnitude of acceleration is V minus U divided by T. Sir, if you want to see your grade 11 way, then acceleration is delta v over delta t, where delta v is v minus u divided by t. And what is t? t2 minus t1, whatever is the time span. समझ में आया? And if somebody has done equations of motion already in your school, then यही से आता है तुम्हारा v is equal to u plus at. इसको अगर मल्टीप्लाई करेंगे क्या आएगा? आटा equal to v minus ya. So v is equal to u plus at. This all we will come later on. So Kahani Ghar Ghar Ki has lot of episodes left. So for today, you understood till velocity. Next class, we will understand acceleration, and you have to feel acceleration. Feel means, do you understand? What is acceleration? Oh, acceleration. What is uniform velocity in noise? This is uniform velocity. Non-uniform. What is acceleration? Like the Yamaha starts. That's acceleration. What is deceleration? Slow हो जाना. ये feel आना है. That's how my sir thought. Unless you feel. Have you seen how a motor start? Oh, go to 3 Idiot. In that case, Mr. Rajiv Rastogi, can you tell how does an induction motor start? He says that. And how does it start? That is deceleration. Have you seen the aircraft taking off? Have you heard that jet blast? That's acceleration. And deceleration is when you slow down. ये सब अगले क्लास में. अगर आपको प्यार है फिजिक्स से, आप पढ़ सकते हैं. And if you say, hey, he teaches so much outside the book. No, I want to make you learn to enjoy the topic. Number everyone will score. See, now you all are about to leave, right? This